Okay.
Go ahead, Alex.
Okay. Well, welcome everybody. I am really grateful to have you here so we can all learn from four amazing scientists who are going to be talking about fire and savanna ecosystems. This is going to be the first of a two-part series on savannas. So today we're going to be providing some foundational background information, and then in our next webinar in another month or so, we'll provide some specific case studies and talk about some special issues. And thank you for all of your interest in joining today. I am amazed that we have registrants from 29 different countries across 6 continents. Wow. Here is a breakdown of where we are all coming from today. So this is a truly global interest in savanna ecosystems. And this series is a part of the Global Wildfire Collective. So if you're not familiar with what we do, I'm going to give you a quick background to describe what we do and what our vision is. So we all know that there's increasing consequences of wildfire worldwide, and we know that the issues are really complex and variable, and we urgently need solutions to deal with these issues. So my co-founders and I developed the Global Wildfire Collective to help facilitate scientific and strategic collaboration across multiple sectors, from scientists and policymakers to firefighters and industry, to facilitate science-based and evidence-based recovery and resilience for both social and ecological systems. We cover a wide range of disciplines, topics, and scales. So we endeavor to be transdisciplinary, but also to help organize and frame our discussions and activities. We've defined 4 key pillars of interest that we're focusing on, including global change, looking at the diverse factors that are driving changes in fire regimes, altered fire regimes, fire ecology and biodiversity, looking at the effects and interactions of fire with natural systems, fire management and policy, trying to focus on integrated strategies to have beneficial outcomes for, again, both social and ecological systems and communities. And finally, equitable community safety and resilience, because we're as safe as our neighbors are, and we need resources for everybody. I also forgot to mention in my first slide that if you have questions during the webinar today, please enter them via the Q&A and we will be monitoring those. So how do we achieve this mission? We are involved in a range of different activities and services. We aim to have collaborative capacity development through trainings and workshops, to understand data gaps, and to focus on people who don't have the access or the science or technology that other people do. Especially, there's big differences between the global south and the global north. We are facilitating research collaborations because wildfire is complex and one size doesn't fit all. And even though we need to increase the pace of resilience and recovery strategies, we need to do it in a smart way, because using one strategy in a different region can actually have the opposite effects than what's intended. So we're doing research and collaborating across regions to better understand how some information and science transfers and other doesn't, and how to account for regional differences when it doesn't. We have created a spatial data gateway, and that's a shared platform where researchers and practitioners can share, find, work with geospatial data and tools. You can have public and private workspaces to work together and collaborate. There are integrated tools within the spatial data gateway that allow you to visualize data and to work with and do analysis of data. Finally, we have a discussion forum, which is a place where members can ask questions, share news, announce events, and just connect. And it's multilingual in 60 different languages. So if you type in your language, you will receive a response also in your language. And we will have links to all of these at the bottom. We're at globalwildfirecollective.org. And a new initiative that we are just launching is a fire modeling literacy program. And we're doing this. One, we had a webinar on fire modeling, and we had such an enthusiastic response, and we had so many participants that we saw a real need to help establish literacy in fire modeling across a range of sectors. So we're hoping to help improve practical understanding of fire modeling, because modeling and methods to analyze and make decisions about wildfire are as complex as the topic itself. So we'll be looking at how do you fit different modeling methods or approaches to different research questions or types of decisions or management strategies, sort of the fit for purpose question. And then how do you interpret model output in light of all of the uncertainty that can be created through modeling? So we are going to be launching a foundational course in June, which will basically be foundations of modeling, just an overview of the diversity of approaches and how to use them, along with some case studies. And then we will be building from there. And to help us to understand what the user needs are, what your backgrounds are, what sectors you're coming from, what your interests are, we have created a user survey. So if you click to the QR code, whichever language you prefer here, you can access this survey, and it would help us be able to best help you. And another thing I'd like to mention about today is that we will be recording this webinar on and hosting it on YouTube afterwards. So if you missed the QR code, you can come back to it. And finally, we have started a webinar series. I mentioned the one on wildfire. And what we're doing now is we are going around the world and presenting foundational information about wildfire issues in specific biomes across the world. So we had one on boreal forests, we had one focusing on Mediterranean ecosystems, and of course today we're going to be talking about savanna ecosystems. Obviously, biome is a term that is defined differently depending on who you're talking to, and there's different methods for determining what actually constitutes a biome. I don't know why these are animated, but some of them are based on combinations of precipitation and temperature, so they're climatic based. So you can see over here we've got savannas, but it's important to also understand that fire is an important part of many biomes, and fire regimes differ not only across biomes, but also within them. And what we're talking about today comes out as having some of the most frequent fire within the system. But this is another view of biomes, and this is a classification on a map. And if you look here, there are actually 3 different biomes that are classified as savannas. So savanna ecosystems are critically important for wildfire across the globe, and they're also very diverse and complex. So our speakers today are going to help us to understand them. And I'm going to move into the discussions now. I think I may have mentioned, but I'll mention again, we'll be presenting, everybody is going to present first, and then afterwards we will have questions from the audience and take it from there. So today we're going to start out with Caroline Lehmann, and she's going to talk about savanna ecosystems, fire and research challenges. Abby Croker is going to be talking about biogeography relative to savanna ecosystems. One size does not fit all. Amos Chege Muthiuru will talk about From Peaks to Plains, Changing Fire Regimes of Kenya's Savanna and Montane Protected Areas. And finally, we have Sally Archibald, who will be talking about biodiversity in savanna ecosystems. And with that, I am going to hand it over to Dr. Caroline Lehmann, who is with the Royal Botanic Garden in Edinburgh, and she's also a professor in plant ecology and biogeography. So I now will I stop share, and I think that means you can share now.
Okay, great. Thanks. I'll try.
Okay.
Hopefully everyone can see that.
It is still rendering, Caroline, but it looks like it's going to work. There you go. You're good to go.
Great. Thanks. Thanks, Alex, and thanks, Robin, and thanks for the invitation. And really nice to be talking with a bunch of really lovely colleagues today. So my job was to talk about what savanna ecosystems are, fire within them, and their associated research challenges. And in a way, I think this landscape in central Madagascar kind of typifies a number of the challenges that I'll touch on around definitions, their dynamics, the role of people within them. So what are savannas and savanna limits and their dynamics? So it's a hugely widespread biome across the Earth's surface. It takes up around 20% of the land surface, of the terrestrial land surface. It's made up of a varying component of trees and also largely tropical C4 grasses. And C4 grasses are really productive. And maybe I hope this kind of segues also gives a shout out to Abby's work, but savannas across these regions are also, they're kind of all savannas, but they're also all quite different as well. So they're limits of savannas between different regions, whether it's in South America or across Africa, Madagascar, South Asia and Southeast Asia and Northern Australia, they really do vary relative to the continental environmental gradients of those areas. For instance, between Africa and Australia, 2 slides here, or panels in the bottom middle and right-hand side of the screen, you can see the limits of both savannas of Africa and Australia. And they're quite different in a way. There's a large difference in the kind of the high rainfall end of that spectrum, where Australian savannas tend to occupy and bridge into a much wetter space. And in contrast, African savannas occupy a much more arid environmental gradient. And there'll be more to that, but there's a lot to do with both animals and fire across these ecosystems. So of course, fire is kind of comes up as synonymous with savannas across the world, but also in places like across continental Africa, still across South Asia. Animals are a really important part, and megafauna have been a really important part of the shaping of the dynamics of these ecosystems for a very long time. And so I guess just to emphasize the diversity of these landscapes, you know, as I've said, they occur kind of worldwide. And what makes up those diversity and those differences is kind of a lot to do with what's in these pictures in terms of what's in their biodiversity. And so Sally will talk about more about that later. What we've got here is savannas across Australia, Madagascar, South Africa, South Asia, parts of Central Africa, and where there's really different constituent tree floras across these regions, whether it's the Myrtaceae that dominate Australian systems, the Combretaceae that dominate many Asian systems, or also some of the different both Fabaceae and Combretaceae, and also different sizzlepinioids that dominate African systems. And that is overlain on this background of there's a really high diversity in grasses, but we see much higher level family level commonalities in the ground layer floras of the grasses themselves. So I've said all of that in terms of these pictures that I've just shown you of kind of different pictures of savannas, of trees and grasses all over the world. And you kind of have this emergent picture of kind of sometimes of sweeping plains of the Serengeti and these big, very open systems. But often savanna ecosystems have an awfully large number of trees in them as well, and they can be very high tree cover. And so for many years, people, I guess like Alex alluded to, have been thinking kind of quite carefully about what is savannas, what's forest, and how do we define biomes and ecosystems. And that's something that there's been some really great work on, and also is kind of quite apparent in savannas, is that it's quite difficult to define them by their structure alone. So a lot of work these days, and particularly when we want to interpret patterns of remote sensing of fire, we rely on that remote sensing imagery. But for example, if we just step back and have a very coarse overview of, for instance, the amount of tree cover that's in these landscapes or in these ecosystems, it can be quite difficult to distinguish actually what's a savanna and a forest from those remote sensing images of tree cover. But equally, if I looked at then integrated more information about the herbaceous systems, for instance, around just total herbaceous biomass, even if it's total C4 biomass, I can also see that structure still masks how I'm understanding these ecosystems as well. So we've kind of, I think, in a bit of a conundrum with savannas sometimes around kind of their definitions, in that climate doesn't really equal biome, and tree cover doesn't distinguish kind of really key ecosystems that we know have really different adaptations and sensitivities to and roles of fire in these landscapes. So that kind of leads us down the path of needing to think about ecosystems as a whole. And here is a really nice field site that we work at in Makwera in Zambia, where we've been doing a lot of biodiversity work. But the point here is that kind of to step back and step into the savanna and think about the ecosystem as a whole. And we're looking at the flora, its constituent parts, its adaptations, to think about what actually constitutes these biomes and these ecosystems, rather than these coarse definitions related to tree cover that we know that don't function with remote sensing. And that's a really important message for policymakers. We know that there's a lot of work at the moment with various nature-based solution interventions that are often centered around tree cover. And when we're just using these kind of coarse metrics or proxies to think about these ecosystems, we're going to miss out on some of the really important variability and understanding that we need to have about these biomes, and particularly how they respond to and work with fire. So here's the snappy GIF of fire changing month by month. And I've put this in because also, like the slide previous, you're kind of standing in the savanna and now you're looking down at the savanna systems. So as Alex was already saying, fire is an incredibly common, frequent element of these landscapes. It's really hard to think about savannas without fire. But what's really important is also to think about what's actually burning in these landscapes. So savannas are, as I said, they occupy a really wide range of rainfall gradients across their continents, but a hallmark of them is also their seasonality. And that seasonality enables essentially the time for the curing of the fuels, which is largely grasses. And so all these large patterns of fire that we're seeing, it's really all of this grass burning. And it's not those trees, you know, it's really that last year's productivity that's being kind of blown away as smoke into the atmosphere. But that's a really important part of their dynamics. And so I guess we can theorize this as well. And I think this is a really nice, simple way to think about it. I still think that this paper by Ross Bradstock from 2010 is like just a whole keystone paper, basically, for fire ecology. And it centers on the idea that energetic constraints limit burnt area, and in savannas in general. And we can think of that as like a y-axis of area burned and an x-axis of productivity. And that x-axis in savannas is nicely conceptualized essentially as rainfall, simply because rainfall is governing the amount, the amount of fuel growth that is taking place year on year within these systems. And so we've kind of got this bell-shaped curve of the amount of area burned, or the amount of fire that's in these systems. And if we're looking at that left-hand side of that graph, it's really driven by the amount of fires ramping up related to productivity. It's about the rates of fuel accumulation. It's about the rates of plant growth driven by rainfall that enables connectivity of fuels and fire to spread within ecosystems. So simply the amount of fire is limited by the connectivity of the fuels in that landscape. And so a number of savanna systems might burn on a 10-year cycle instead of an annual cycle. And this is fundamentally largely underpinned by rates of productivity. Then our productivity is peaked. This tends to be our kind of pretty wet savanna ecosystems in the Yombo, Northern Australia, parts of the Cerrado. And these are highly productive landscapes. They're producing huge amounts of fuel year on year. And then as you're ebbing into the tropical forest systems, really what's limiting the amount of fire is the availability of that fuel and its capacity to cure through a year. And so this is where the contraction of the dry season or high rainfall areas that don't have sufficient windows in order for fuel curing to take place, there tends to be less fire in them. So if we can think of this kind of role basically of the amount of fuel that is growing year on year in the form of these grasses and the capacity for that fuel to be cured through the seasonal dryness of these systems, we can largely think about and predict the amount of fire that's in these landscapes. But there are also other really important constraints and modifiers of burn area as well. This is really nice work by Sally Archibald and her colleagues, where they've looked at also the roles of animals in these landscapes and also the role of fragmentation in landscapes. And because savanna fires is essentially driven by the amount of grass that's in landscape, these fires are also pretty low intensity. They're it's really consuming these grasses. They happen frequently, but they're quite cool fires. And so the amount of fire in these ecosystems, because it is such frequent and cool fire, is readily able to be modified. In terms of animals, for example, herbivores, there's quite the trade-off between the amount of animals that's in a system and the amount of fire. And basically a choice in the ways in which that grass biomass is being kind of sent back out to space, either as farts and poo or as smoke up into the landscape. And then equally, people have a huge role to play in modifying the amount of fire that's in these landscapes through fragmentation, through land use change. And of course, fragmentation just prohibits fire spread. And so the more fragmented the landscapes are, the harder it is for fire to spread across those landscapes. There might be many small fires, but it takes many, many small fires to make one large fire. So with that, this has been a rapid fire run through, but at the heart of it, savanna fire regimes across the world are both globally variable, but also similar. They're similar in that the same fundamental principles of grass growth and curing drive the amount of fire in those ecosystems. They're also globally variable because of the patterns of people and the way in which we change landscapes and manage landscapes across the world. They're different because of the different types of animals, the ratios of livestock or mega herbivores across the landscapes. They're different because of different political priorities across the world. So there's a great basis for understanding the commonalities of these landscapes in terms of their amounts of fire. And I put this massive graph up here. This is from some work from a previous postdoc, Leanne Phelps. And in this particular piece of work, we were trying to do some myth busting around the role of fire in Madagascar, where there are a number of anecdotes, for instance, around too much fire, too little fire, many hot fires. And so we kind of looked at that and really found that actually there's a lot of commonality in the fire, for instance, across these regions. But then we also find that there are quite unique regions. Those unique regions on this map are actually shaded in black. And you can see that in different parts of Africa and across Australia. And they're largely driven by the fact that they're quite unique climates as well. So then I was also given the brief of some research challenges to think about in this presentation. And I kind of wanted to say that savannas remain contested. I've given you what I think is kind of a clear-cut view on savannas, what they are, and fire. But when I interact with policymakers, with other researchers, with practitioner groups across the world, I can see, and as Alex also alluded to, there can be poor or limited agreement on their definition and their identification. And that has a real flow-on effect to how we manage things and how we understand things if we're not actually agreeing on what something is and we see things through quite different ways. Then savannas as kind of open ecosystems with a lot of fire in them. they're often perceived as areas of arrested succession through disturbance. And that's where fire or animals are actually holding those ecosystems back from being a climax state of forest. And that's kind of, in a way, dismissing their kind of unique ecological roles, their unique relationships with people across the world as well. So that's a really important kind of idea that we need to think about. Scientifically, there's quite a protracted debate around alternate states as well, and the role of fire in these systems as well. And this is a very persistent thing in the scientific literature, but it can be a bit of a red herring, also with needing to think about biodiversity. And then we've got a kind of a series of more management-oriented kind of contestations that come up very commonly around, well, people create open ecosystems, people create savannas, therefore savannas are degraded landscapes. This is something we hear quite commonly across different parts of the world that we're working in. Fire extent is only a product of people, and therefore all fire is like not natural. And that's simply not the case. Often when you have many, many people, you have actually far less fire in these landscapes. Grasslands only exist because people clear forests through fire. This confounding of agricultural fire with savanna fire is something that really needs to be tackled about because of perceptions related to how that fire is then managed within ecosystems, where things are perceived through a disaster lens instead of actually through a regime or a systems-based lens. And then also this idea that there's more trees in the landscape, therefore there's more biodiversity. And in that sense, it's then always conceptualizing fire as a filter on a landscape. And I think we need to pivot around to thinking also how fire is a facilitator. We can't have a talk on savanna fire regimes without talking about this kind of really widespread and very rapid decline we're currently seeing in the amount of fire within savanna ecosystems around the world. And this is largely because these systems are such bellwethers of change. When they have these kind of sub-decadal fire regimes, the change and the rates of change that we have the capacity to observe, even with our relatively short remote sensing records, is very high. And we're still kind of really challenged in understanding, what does this change mean? How do we manage this change? And how does it affect people? How does it affect biodiversity? One thing I think that it does kind of affect in terms of that changing fire is also thinking about savannas as mosaics. And maybe this is also where this talk around biomes kind of comes in. Is, to me, this is like a landscape, and in a way I actually see 3 or 4 different biomes within this one image. Oops, sorry, what happened there? One image of central Madagascar. We've got our kind of fire sheltered forest, we've got some flooded grasslands, we've got an open grassy plain and some savanna patches across a hillside. But what happens when you kind of are losing fire from landscapes is that doesn't automatically protect what might be more fire sensitive ecosystems within these landscapes. So in terms of managing these landscapes of fire, they have each of these different biomes have different relationships with fire. But our capacity to just manage this as one uniform amount of fire in that ecosystem does a disservice or increases the vulnerability of other ecosystems within that. So I would say that declines in fire within grassy systems, what we're seeing at the moment, is not an automatic kind of protection for fire sensitive ecosystems within that mosaic. Rather, it is rapidly increasing their risk to extreme fire that can't be managed and that we know is increasing because of climate change. And just in many parts of the world, that capacity for the record and understanding of climate change and climate change impacts on fire is very low because of the monitoring that just isn't possible on climate. Because fire is changing, it also means that savannas are changing. So they're changing really rapidly. We know that there's the process of encroachment that is happening really rapidly. We know that fire is changing, fire losses. There's increasing amounts of increasing amounts of livestock, decreasing amounts of wildlife. all of this is absolutely changing the dynamics of these savanna ecosystems, and our understanding of those impacts and actually how we manage that to support resilient savanna ecosystems, I think is really still a very big challenge, because of course this is very context specific as well. This will be unique to the ecology of a region, to the cultural context of a region, and it's something that really needs a lot more work. I just touched on this briefly before, and I think that this is something that really does need more discussion and discourse, particularly within policy frames, is the confounding of agricultural fire with savanna fire. Often we hear about slash and burn and conversion, and I think because agricultural fire creates then an open ecosystem that might be ploughed fields, the idea that then this is also essentially a savanna system as an open grassy system is a real misnomer and a misdirect in terms of then thinking about how to manage fire in these landscapes as well. This is just also the final point, effective use and access to high resolution remote sensing. This is actually a really dry point to decide to end on, actually, but I think it's a really important one, because I think it was really nice to hear Alex mention the opportunities for kind of foundation modeling courses. But, you know, over the last 25 years or longer, our understanding of fire in the Earth system has been completely revolutionized by using kind of this core scale remote sensing from Meadows. And we're really transitioning now into an era of using much finer resolution information through Sentinel, which of course has a smaller footprint. And all of a sudden we're detecting and understanding potentially much smaller fires. And so a lot of that theory kind of that has emerged and developed, I'd say, out of that kind of data model fusion that's come through Meadows, I think needs to kind of now think about how do we incorporate smaller fires and a better understanding of our capacity for that remote sensing into that. So concluding thoughts. Savannas, they're a global bellwether of fire. They're changing incredibly quickly. And in terms of managing those landscapes for all things, we need to be adaptive, and we need to manage fire regimes, not fires, move away from a disaster lens that where despite fire being an incredibly common integral part of the deep time kind of evolution of these systems, of deep relationships with people, there's still often a disaster lens put upon fire in these landscapes. And I guess that comes to that point of evaluating the basis of our assumptions around fire in savannas. I think that's something we can all kind of step away and do. And we can see these important commonalities across regions. And really, I think that's what Alex and Robin are trying to achieve here. We can reflect on the kind of the basis for our shared learning and knowledge exchange by kind of thinking about these patterns across regions and where the differences and the commonalities might be. We need to think about how fire can be managed across landscapes. So that's incorporating these mosaics of fire-sensitive systems and fire-prone systems, and how we manage that for resilience in a changing world. Thanks very much, and I hope that was helpful.
That was excellent, Caroline. Thank you so much. Such a great summary of such a broad and diverse topic. We are now moving to Dr. I think I should share my screen again. Okay, I am gonna get good at this. Share. Okay. Oops. Sorry. I have to go through. Here we go. We now have Dr. Abigail Croker. She is with the High Meadows Environmental Institute at Princeton, as well as the Leverhulme Center for Wildfires, Environment and Society in the UK. So I will drive for Abby. So just let me know when you're ready and I will click.
Great, thank you so much. Yes, so today I'm going to be talking about some of the research I carried out during my PhD when I was based at Imperial College in London. So I'm going to be talking about like how a biogeographic lens can inform adaptive fire governance. Really thinking about how a one size does not fit all. I'll be talking about sub-Saharan Africa, specifically South and Eastern Africa, and then also Northern Australia. I think Caroline's just done a great job of highlighting all the other savannas in the world, but for this case study, I'm just going to be focusing on those two regions. Yeah, so firstly, just some context in the area of my research. Oh, thank you. Thank you, Alexandra. Next slide.
Sorry.
You're ahead of the game. Yeah, so my research really focused on disturbance-driven African savannas. So like Caroline highlighted, they're exceptionally biodiverse, a mixture of like large intensity, high intensity and low intensity fires, and dominated by the seaforth grasslands, which are highly productive under increased temperatures. And they also store a lot of below ground carbon. These savannas really have co-evolved with diverse human fire practices that have supported different sociocultural aspirations, livelihoods, and local economies. And then today, they also support a really high percentage of sub-Saharan Africa's population, most of its rangeland and livestock biomass, and also Earth's last remaining extant megafauna. But since the late 1800s, colonial fire suppression has criminalized fire use, and exclusionary protected areas, which have got rid of all people and their livestock and their fire use practices, have driven processes of ecological hysteresis, which you can see on the left-hand side, and biocultural hysteresis, which is the erosion of the human-environment relationship. And this has resulted in a wildfire paradox, where we find that the suppression of fire has resulted in large wildfires, largely concentrated inside protected areas. And these are really high intensity, typically in the late dry season. But then also outside of protected areas, as Caroline highlighted, there's been a complete decline in total fire, where there's a lot of population growth and sedentarization. So there's a lot of fuel being removed. And Sally carried out a wonderful study that showed how livestock have replaced fire as the dominant fuel consumer in these ecosystems. Yeah, and I just highlight this framework because I like to think about the wildfire paradox as this kind of joint adaptive cycle framing that includes both these processes of hysteresis to really emphasize the kind of how fire is really a social ecological phenomenon, and how actions like taken to control fire and human nature relationships can prevent the long-term resilience of such fire adapted ecosystems. Next slide, please. Yes, so one of the things I looked at during my PhD was that to address this wildfire paradox, we increasingly saw literature proposing community-based fire management because it, first of all, recognizes the dual role of fire as both can be bad in the case of extreme wildfires in these protected areas, but then also really good because these savanna ecosystems rely on fire. And then also because it would enable equitable local governance as it's community-based, it's bottom-up, locally adaptive. So it really supports the sort of bioculture of the local place. So a few things I wanted to look at was when looking at the nature, framing, and extent of community-based fire management across sub-Saharan African conservation landscapes was project establishment, so who initiates these projects, the sponsorship, who funds them, decision-making, who actually holds decision-making authority, and then also participation, so the level and willingness of involvement. And the key findings really were that these projects, despite being community-based, are externally initiated, externally funded, and mostly in hybrid governance arrangements where centralized authorities retain decision-making rights. And so, yeah, the common kind of issues throughout these projects was limited local participation in even the design of the project, insecure land tenure, they don't have rights in protected areas, and also then this continued emphasis on fire suppression and prevention. And actually, one of the main things I found in this review was that there's an emerging shift. So it's this integration of traditional fire knowledge into modern management systems, often aiming to revitalize cultural burning. But then also this kind of standardization of traditional fire knowledge into early dry season prescribed burns, really aiming to shift the fire seasonality from the late dry season to the early dry season. And one of the main insights, which again Caroline has highlighted, is this rise in payment for ecosystem services schemes that are linked to carbon markets. So today I'm going to focus on the savanna burning emissions abatement schemes. Next slide, please. I also just want to point out while we're here, this is not a critique of these schemes in the context that they have originated. Just raising the considerations of the kind of things we need to think about when assuming these sorts of models can be transferred. So just a little bit on the savanna burning emissions abatement schemes. First of all, they're often framed as indigenous led. So some context here is the Australian model is basically based in the Northern Territories, where there's 1.9 million kilometers squared of these eucalyptus dominated savannas, of which 20% of these savannas burn annually under late dry season wildfire conditions. And these fires contribute towards more than 50% of the Northern Territory's annual greenhouse gas emissions. So the core idea of these projects was to shift the fire season from the late dry season to the early dry season, really to reduce emissions and wildfire intensity. And this is a Kyoto Protocol compliant activity, which countries can include in their national greenhouse gas inventory. So in this context, its landowners and landholders can carry out prescribed early dry season fires to offset late dry season fire emissions. And what they do is then they receive carbon credits for each metric of ton of CO2 equivalent stored or avoided. And then they'll sell these carbon credits either back to the Australian government or to private companies to offset their emissions. And these are often associated with large developments. The development projects are allowed to emit a certain amount of carbon that's equivalent to the amount abated. And then also just context in this environment is that the land across this region is really mostly for pastoralism. It's expansive. There's also conservation, and vast expanses of it are indigenous owned or held. So by entering or establishing these savanna burning schemes under the government's emissions reduction fund, the Aboriginal landowners or holders can acquire carbon benefits through the offset of these emissions. And in this landscape, it does provide some diversified income opportunities where other opportunities might be limited. So there's now two types of these projects. One's the classic emissions avoidance. So a reduction in savanna greenhouse gas fire emissions through a reduction in the frequency and extent of late dry season fires. But then there's this more recent introduced methodology, which is sequestration and avoidance. So that is also, as well as avoiding emissions, it's also increasing the amount stored in woody biomass, so carbon sequestration. This has probably expanded since then, but as of 2019, there were more than 70 projects across the Northern Territory, and it is just increasing, especially with the new guidelines as well. Next slide, please. So why Africa? So there was a really interesting study that basically highlighted why sub-Saharan African savannas provide a great place to basically transfer this model. So African savannas are responsible for more than 60% of global fire extent, also for 71% of global savanna CO2 emissions, but then also more than 80% of annual large fires occur in the late dry season and are concentrated in protected areas. So this study found that there was quite a lot of high potential to offset these emissions in African savannas, especially in least developed countries. And within these 17 least developed countries, there were more than 197 candidate protected areas, covering total of 1 million kilometers squared. And these together have the collective potential to abate 37% of global savanna burning emissions. But also this is quite appealing in this context because there's been a huge rise in REDD+ programs and also other carbon market mechanisms. So it's a way of it's climate finance. Also, it's a national incentive because it can generate some money. The only problem and caveat here is that it does these carbon credit schemes often do promote fire suppression and forestation, which I will come back to. So I guess my leading question here was, can savanna burning emissions abatement enable effective and equitable bottom-up governance in African savanna protected areas? Next slide, please. So I wanted to explore this through a biogeographic lens. So this biogeographic landscape just shows that fire regimes really are a product of these different variables. So the biogeophysical landscape, the topographical landscape, and also the socio and cultural context. And really, it just goes to show like how atmospheric conditions, consumable biomass, so these fuels, and ignition agents all interact to shape fire regimes. And I really like this framework because it really shows how fire exists in practice. So it's dynamic, interconnected, and shaped by both biogeophysical and environmental conditions, and also the built and social environment. Um, Next slide, please. So yes, we carried out a big systematic review of the literature in order to basically look at how implemented savanna burning emissions abatement projects and proposed projects were kind of like rolling out across eastern southern Africa. And part of the biogeographic kind of lens really emphasizes context. So we wanted to identify contextual factors that set this region apart from the rest of the world. So we identified three factors really that affect opportunities for effective and equitable fire governance in this context, and that's population growth, climate change, and its really recent complex colonial history. And then, as you can see from this framework, we also identified three main biogeographic assumptions that are informing the transfer of the Northern Territories model to sub-Saharan Africa. And that was, first of all, nutrient poor. Both share nutrient poor mesic savannas with marked distinct wet and dry seasons. The second being extensive protected area networks characterized by low human and livestock populations and frequent intense wildfires. And third, indigenous-led projects. So that's pastoralist societies have accrued analogous fire strategies, producing similar heterogeneous landscapes from early dry season burning worldwide. Next slide. So now I'm just going to go on to just briefly go over the contextual challenges and then go through each of the focus challenges. So first of all, contextual challenge number one, as you can see on the map, this region's got a really complex colonial history where prior to the Berlin Conference in 1884, only 10%, which was actually more informally colonized, was under some sort of a European colony. And then after the Berlin Conference, more than 90%. And that basically divided over 1,000 local indigenous polities into 50 irregular states. And these colonial regimes really did focus on resource extraction. And then even today, neocolonial interventions often impose a lot of green conditionalities on conservation development projects. And also these projects themselves are increasingly being prioritized based on their climate finance potential. Next slide, please. And then we have population growth in sub-Saharan Africa is the highest in the world. We're currently at 1.1 billion in 2020, and it's expected to rise to between 3.8 and 5.7 billion in 2100. There's also a lot of high rates of urbanization and insecure and informal settlements, which are creating a lot of conflict and land disputes. And next slide, please. And then finally, the last contextual challenge is climate change. So the rise in temperature across sub-Saharan Africa is above the global average, and Southern Africa has been named the continent's hottest spot, which is warming 4 times faster than the global average. And you can see that fire-prone weather has intensified. So the fire seasonality is now more than a month longer than it was in the 1980s. And then there's also this intensification of the Earth's climate system. So when I was carrying out my research in Kenya, they were on the end of a 3-year drought. And because of that, there was a lot of increased resource conflicts and then agrarian fires that spiraled into wildfires. So now I'm going to go on to the assumptions. So we'll just go through the assumptions number one. So there's perceived similarities between nutrient-poor mesic savannas marked by distinct wet and dry seasons, and that also harbour low mammalian populations. So this is taken from Caroline's paper that she showed previously. And the key differences, just to highlight, so Northern Australian savannas, as previously highlighted, are really fire dependent. So that's the bottom graph here, are really fire dependent across the full precipitation gradient. And they persist even under high rainfall. And then at the arid end, fire precedes and maintains savanna structure because a lot of eucalyptus species rely on epicormic resprouting after fire. And also in the faunal context, they have relatively low mammalian biomass. Actually, they rank in one of the world's lowest. Yet despite that, a lot of this, you might hear the term pyrodiversity begets biodiversity. A lot of that narrative stems from Australia. And yet it really focuses on biodiversity being these low intensity early dry season fires, which, like we've mentioned, is quite problematic. And then in comparison, African savannas, especially at the arid and where there's a precipitation limited, savanna precedes fire, and it goes to show the role of rainfall and herbivores also regulating vegetation in these ecosystems. And then on the mesic transition, so more than about 1,000 millimeters of mean annual precipitation, there's a strong overlap with the forest ecosystems. And in these savannas, they really do rely on high intensity fires, often to prevent canopy closure and maintain savanna. And again, as Caroline mentioned, we also have to look at the facilitative role between herbivores and fire. So in the faunal context, African has got one of the highest megafaunal biomass globally, and ranking like one of the top in the world. And also there's a strong fire herbivore feedbacks. So although it is often deemed as competitive, it's also facilitative because both of them maintain open structures to allow the others to pass through. So that just goes to show the kind of differences here. But also the fact that what we have to be really careful with these schemes is that they often are targeting African savannas that have that receive more than 600 to 700 millimeters of mean annual precipitation, and it's in exactly these ecosystems which says that these savanna burning schemes are actually incompatible with savannas that can experience woody encroachment. Yet these are exactly the savannas that they're targeting because these are the ones that require high intensity fires to maintain an open structure, or they are prone to woody thickening. So there's a bit of a contrast there. And then if I go to the next slide. So if we go to the assumption number 2, which is this kind of a presence of extensive protected area networks which emulate northern Australian savanna rangelands. What we see in Northern Australia is that, you do have a low population density, remote and very largely unfragmented. And also a lot of people in Northern Australia have secure Indigenous and land tenure rights under the Aboriginal Land Rights Act and Native Title Act. So Indigenous communities are often landowners and managers, so they are actually the direct beneficiaries of these carbon revenues. However, in the African protected area context, these are predominantly state-owned and exclusionary. They have often fixed and contested boundaries where customary land rights are really not recognised in national legislation. And then there's also a lot of fragmentation from tourism and infrastructure. And then, as you can see from this map, a lot of population pressure from the surrounding areas. So actually, in this context, pastoralists and Indigenous communities are highly marginalised, are often excluded from decision making and land access. Also face persistent anti-fire narratives. They have like limited property rights. So if I go to the next slide. And then assumption number 3 is this idea of the accruement of similar fire management strategies practiced by Indigenous landholders and pastoralists across the 2 regions, and also their interest in diversifying income through carbon benefits. So savanna burning emissions abatement schemes are positioned as an Indigenous-led kind of conservation development solution. But our review really kind of reveals where this breaks down. And the first one being its participation without consent. So although Article 6 of the ILO Convention 169 on Indigenous and Tribal Peoples says that there needs to be free, prior and informed consent when developing carbon offsetting projects, no country in this region in sub-Saharan Africa has ratified it. So local people, there is no requirement for local people to be involved in project design or the governance structures, and there are also no formal safeguards ensuring their access to land or access to carbon revenues. So really in this context, participation does become instrumental, and often from my research, it showed that actually a lot of it is to it's kind of tokenistic forms of participation, really to modify local behaviour to actually just reduce human-wildlife conflict and these agrarian fires from breaking out. And I just wanted to highlight on the left, again, this is no criticism, it just goes to show that it's really more of a transfer of fire knowledge, because actually there was an exchange carried out between an organization in Botswana, and really the burning methodologies were actually predefined before engagement. So the aim was to go and teach these pastoralists the Northern Australian techniques, and then they concluded that they pastoralists produce these similar heterogeneous landscapes from early season burning. So really it kind of reversed the premise of Indigenous-led approaches, and really kind of like it felt called more spoke more of a top-down sort of governance framework. Um, yeah, so I guess I'll skip to the next slide in case of time. But I really wanted to just highlight here that like using a biogeographic framework kind of makes clear that fire regimes really aren't like they're all very context specific, and you can't just transfer kind of management frameworks from one context to the another without really looking at the kind of the biogeographic variables. So that's the biophysical conditions, the environmental conditions, and the socio-cultural conditions, and how they all interact. Um, and so, yeah, I feel like I just wanted to highlight how, yeah, these interactions really do vary across space and time and scale. And for effective long-term fire management, really do need to take this sort of like contextual biogeographic lens. Thank you.
Thank you so much, Abby. That was such a great case in point about knowledge transfer, and I learned a lot from that. We now are going to move on to Amos Chege Muthiru, and he will be talking about fire in Kenya, and I will stop sharing so Chege can, you can share your screen.
Thank you very much. I hope you can see my screen.
It is still resolving, but it is, yes, now we can see it.
Good. Thank you very much. Thank you very much for the previous presenters for the good introduction. So my name is Chege. I'm a PhD student at King's College London. And I'm working on fires in protected areas. And for today, I'm going to contrast between two critical ecosystems, which have been mentioned very many times in this webinar, which is savannas, and to contrast the fires in savannas with the fires on the mountain protected areas in Kenya. So as it has been mentioned, fire hasn't been much used in these protected areas because of colonial regulations, which were set many years ago. And therefore, the rules and regulations that are implemented in the country were made during that time, isolating people from using fires in these protected areas. And therefore, there has been a lot of changes and a lot of retaliations, as my colleague has mentioned. There has been illegal use of fires in these ecosystems over the time. But this is also changing with seasons and time, as I'm going to show now. So to begin with, as Abby has mentioned, fire is now mainly affecting protected areas, mainly in Kenya, because most of the land is actually a desert on the northern part of the country. And also the protected areas are the ones where we have a lot of biomass that burns when fires occurs. So these protected areas, as it has been mentioned, they are key habitats to wildlife and mainly source of income to many of these African countries, and also have a lot of endemic and threatened species and endangered species that are key biodiversities for most of the parts of Africa and also globally. So these protected areas are disproportionately affected by fires, as we've seen before. And this is due to changes in land use, fragmentation, as well as changes in climate that is happening now, leading to severe wildfires in these protected areas. However, we lack accurate data to show the trends of the fires in the protected areas and how susceptible they are to these fires because of lack of high spatial resolution analysis, because most of the data that has been used are actually on a very high, low spatial resolution, and cannot account for smaller protected areas that are very critical in these ecosystems. So we analyzed burnt areas since the year 2001 for the main reason to try and come up with accurate metrics of some of the protected areas in the country and help protected area managers in doing their own budgeting and also when they're doing resource allocations in terms of managing fires in these areas. So to begin with, we narrowed down to specific protected areas, mainly because we cannot map all the protected areas in the country, although it is doable. But we choose some selected key areas to map the burnt areas and also identify the trends in these burnt areas, in these key protected areas, and also look at the susceptible areas in those protected areas so that we can be able to help the management to address the threats of fires when they happen, and also identify the factors that lead to these protected areas' susceptibility to fire. So we contrasted two montane ecosystems, which are also somehow transboundary, like the western side of Kenya, where we have Mount Elgon, which is a transboundary ecosystem between Kenya and Uganda, and Aberdares National Park, which is at the heart of the nation. And we also looked at Masai Mara, the famous, due to its famous migration of wildebeest from Kenya to Tanzania. And we also looked at the Tsavo Conservation, Kenya's largest conservation area, and also host very critical species in the country. So these areas are the ones that are most affected by the fires because because of various reasons, and one of them is being proximity to the people and also accumulation of biomass. And when fires happen, then these ecosystems are very much threatened. They also form sources of water, like the Mount Elgon and Aberdares are key sources of water for the country and also for hydropower generation. And Masai Mara is a key tourist attraction for the country, earning a lot of income from that. Tsavo hosts one of the Kenya's largest population of elephants. Up to 34% of elephants actually occur within this landscape. So to achieve our objectives, first, we mapped under high resolution, that is using Landsat images to look at the fires, where they occur and how consistent they are within these protected areas, and compare the trends between the two ecosystems as well as map the factors that lead to this protected area susceptibility. So we used Google Earth Engine and of course random forest processing within the Google Earth Engine framework. So the results shows that savannas, of course, burn more than the montane ecosystem, and this is based on the size of the savannas and also the activities, the human activities occurring within those ecosystems, as I will show later. However, we found contrasting results between the ecosystem and as well as between the protected areas. For the case of Aberdares National Park, or the protected area, which includes its forest, we saw increasing trends on burnt area as well as the proportion of the park that burns annually over the time. For the Mount Elgon, which is also a montane ecosystem, we saw a reducing trend in terms of the burnt area over the time. For Masai Mara, there is a significant increase in trends in the burnt area for the Masai Mara as well as the proportion that burns annually. And this is mainly because of changes in human activities adjacent to the park. Similarly, for Tsavo, we found a declining trend, but importantly, there are frequent severe wildfires that are occurring occasionally within these protected areas. So that we need to have that in mind. For temporal, we also looked at how the monthly burning, how it happens. And interestingly, the two ecosystems burn differently throughout the year, with montane ecosystems burning at the beginning of the year and savanna ecosystems at the tail end of the year, which is what Abby was describing as the late dry season, sorry. However, in Masai Mara, the trend seems to be a little bit different compared to Tsavo, with which, whereby the trend seems to be burning from January all the way to December. So we interrogated why that is happening, because we would expect Masai Mara to burn at the end of the year, similar to many of the savanna ecosystems. And we realized that that trend has changed in the recent past, whereby burning changed between the year 2012 and 2022 when we did the analysis. Changing from the late dry season in the previous season of 2001 to 2011, whereby it was burning at the end of the year, and breaking that into two seasons, at the beginning of the year and at the end of the year. But that has changed within the two decades that we analyzed the data. So we further looked at how that has changed over the months, and interestingly, the fires are moving from the late dry season, which is the month of October, to early August, or to August, and which is significant, and also changing spatially between the areas that have been burning before to increase in terms of the burnt area, as I've shown before, and also spreading more into the park than before. In terms of susceptibility, we also mapped the areas that are highly susceptible to fires and also quantify that, so that when we're doing the budgeting for wildfire management, then we can be able to have an approximate area that is likely to burn if wildfire happens. And this is important for the management. Importantly, the size of Savo would be like 3 times the size of Masai Mara, and talking about 11% of Savo is a very big piece of land that burns, that can burn annually. However, one of the park, which is actually at the northern part of Savo, which is Chulu, it's highly susceptible throughout the year because of frequent fires and a lot of human activities happening at the surrounding areas. We interrogated the factors that lead to this area susceptibility to look at why some of the protected areas are more prone to fires and others are not. And we found that protected areas that are close to human activities such as agriculture, which include the Masai Mara and Mount Elgon, are more vulnerable to human-related fires. Rainfall and NDVI, which is the state of vegetation and temperatures, were also key model predictors, showing that fires happen when the rainfall reduces, especially for Abadeas, and also temperatures increase. And that is the beginning of the year in Abadeas, for example. For the Savo, there is a very long dry season within the year, and fires are therefore influenced both by the rainfall, the temperature, and also distance to agriculture. And this is mainly for Chulu National Park, which is mainly influenced by fire. Interestingly, by human activity, sorry. Interestingly, for Masai Mara, proximity to agriculture and distance to built-up areas determined was one of the key predictors of our model, showing that those are the main drivers of fires in Masai Mara. To conclude, it is evident that the existing legislation on fire management do not adequately address the wildfire challenge in these protected areas, and therefore we need to review that. And fire regimes and seasonality in some of these protected areas are changing and is mainly influenced by the climate and human activities, and are also site-specific rather than ecosystem-based. Protected areas prone to human activities, as I've shown before, they burn more than the climate-driven fires, or protected areas which experience the climate-driven fires. We provide a few recommendations, including the review of the policies existing for the fire management in the protected areas, so that we can be able to address the increasing frequent severe wildfires that I've mentioned before, and also increase the partnership and collaborations between stakeholders working in these protected areas. We also need to rethink about sustainable transboundary landscape fire management, because most of these landscapes are transboundary, and fires originate also from other countries like Tanzania, where we're having prescribed burning happening in Serengeti, and these fires sometimes getting into parts of Masai Mara. We also need to integrate indigenous people and local communities and their knowledges in fire management systems. As Adi has mentioned, they were excluded from the existing policies, and therefore we need to rethink our strategies of fire management by including their knowledges and reduce the historical injustices that were done when these policies were developed. We look at site-specific management plans rather than ecosystem-based, and we have started that process here in Savo of developing the integrated fire management plan in partnership with various organizations as well as the local communities, so that we can come up with the first integrated fire management plan for the Savo ecosystem. So this is a work in progress that we are working on, and we hope that it is going to be an inclusive framework that is going to address the increasing challenge of wildfires that are happening frequently. I would like to thank the Wildlife Research and Training Institute for granting permits for this research, as well as the NACOSTI, and this work has been funded by King's College London and the River Hume Centre for Wildfires, Environment and Society, and we've been working in partnership with the county government of Taita Taveta, the Kenya government, and also Kenya Wildlife Service and the African Wildlife Foundation, as well as Taita Taveta Wildlife Conservancy Association. Thank you very much for your attention.
Thank you so much, Chege. I'm hearing an echo. That was another way of doing a pyrogeographic analysis, except this time it was not among continents, it was within countries. So that was a great follow-on to Abby's talk. And now I would love to introduce you to Dr. Sally Archibald, and she will be presenting on biodiversity issues in savannas. So you're up.
Hi, thank you everyone. It's really lovely to be here. It's really lovely to have had 3 fantastic talks to introduce the topic that I'm going to be discussing today. Can you see my screen okay?
Yes.
Great. Yeah, so we've zoomed around the world from really global to some quite fascinating local context. I was asked to perhaps try to zoom out to think a bit more globally around fire and biodiversity and what it means for how we conserve tropical savanna systems. So I think it's probably good, if we're thinking about conservation, to think about where these systems came from in their evolution. And the most important point, which I think Caroline has already made, is that savanna fires predate people, and these ecosystems evolved with fire. Here's a figure on the right from a paper by Edwards showing that over the last 20 million years, different parts of the world have slowly shifted from being more closed canopy forest ecosystems to become these open grassy ecosystems that we know today. The yellow colors and the orange colors are C4 grassy vegetation. And then here is a slightly more local measure from the Atlantic Ocean of how much charcoal has been pouring into the Atlantic Ocean over the last 70 million years. And it's very clear that at the same time that there was this shift to the open grassy vegetation, there was a massive increase in the amount of biomass burning. This is mostly in Africa, but we can assume in all of these tropical systems as the grasslands spread across the world. And then just to point out that this increase in burning could not have been created by people, because people only really evolved about 1 million years ago. And to our best of our knowledge, they really started to be able to control fire about 200,000 years ago. But associated with this change in environment and the spread of fiery ecosystems was a diversification of a bunch of organisms that had adapted to these systems. One of these types of organisms is something that we call an underground tree. These are trees whose closest common relatives are big trees with large stems. But at around somewhere between 2 and 15 million years ago, across wide parts of the phylogeny, these organisms evolved in these tropical systems to lose their stems and to become these fire-adapted, resprouting organisms that complete their life history in the fiery grass fire zone. And anywhere you go in a wet tropical savanna, no matter whether you're in South America, I just came back from Brazil, or Africa, you find these underground trees. There'll be dozens of them in the grassy savannas. Evidence that there's been a lot of time for organisms to evolve with fire in tropical savannas. It's not only plants that have evolved with fire. This is a fantastic bird that we are studying with my colleague Claire Spottiswoode from UCT, the bronze-winged courser. Its eggs and its chicks have evolved over a long period of time to be dependent on the burn scars that happen after fire. They are uniquely camouflaged. The birds look like ash, the eggs look like ash, but the birds actually look like burned grass tussocks, which as a grassland ecologist, I find just charming. I hope you can all see the little chick there. Sometimes people can't. There's its beak and there's its eye. And Claire and her colleagues have shown that these chicks are beautifully camouflaged in the burned landscapes that happen after the Savannah fires. There they are in the corner, you can see them there. But they've demonstrated that these birds actually, they benefit from the burn scars because they have higher survival rates for their chicks. And across the ecosystems, we have these fantastic plants that are evolved to take advantage of the change that's happened after a burn scar. And the flowers, we've got these flowers that come and burst out after the ground immediately after the fire, sometimes within hours. You'll have, or within weeks, you'll have these fantastic flowers and diversity. So just to summarize, that we've got plenty of evidence that these tropical ecosystems evolved with fire. But what sort of fire? That's really the question that it's quite difficult to answer. As Caroline and Abby and Amos have pointed out, fire regimes are also changing. So we've got changing fire regimes in these huge swathes of tropical vegetation. We know that the organisms are adapted to fire, but we don't actually know what sorts of fire regimes they're evolved with because there's been so many changes to our ecosystems since then. We also know that people can influence the fires that burn in tropical savannas. People aren't totally in control of fire in any ecosystem, and certainly not in savannas, but the way that we engage with our landscapes and engage with fire can alter the fire regime. So that gives us the potential to have management of fire in these systems. So then how do we engage with biodiversity conservation and fire? What sorts of fires should we be trying to enable in tropical savannas? This is a photo also taken by Claire Spottiswoode of one of our colleagues that we work with in northern Nyasa in Mozambique. And the people there use fire as a tool to calm down bees so that they can harvest honey. And these fires are usually quite calm, but occasionally they get out of control. But this interaction with fire and bees and savannas has been going on for many, many hundreds of thousands of years. I'm going to skip over this a little because I think it's been summarized really well by the other people, that like the fascination of these systems is that they can go, this is actually the same environment. Can you see that's the same tree? So within 6 months, they can go from this lush, vibrant green universe to a really dry ecosystem that is incredibly flammable. Like the fine grassy fuels ignite very easily once they've cured and once the relative humidity goes down. So depending on when the fire happens, whether it happens when the grass is still green, and then you get these sort of slow creeping fires that emit a lot of they smoldering combustion, emitting a lot of methane, but burning less of the biomass, to later in the year when the grass is dry, in which case you have hardly any methane emissions, but often the fires are more intense and can kill trees. And sometimes the biomass can accumulate quite a lot. So you can have 10 tons per hectare of biomass, which all goes up in one huge conflagration. So on a global scale, these fires are not that intense compared with what happens in Canada. But depending on the biomass and the weather, you can have fairly intense fires that can do quite a lot of landscape transformation. I think everyone's showed this already, that we just have, it's the large area burned, but I think that's what I want to zoom in on, is that a large area burned doesn't always mean a high fire intensity. So here's a park in Zambia, in one of the parts of Africa that has the most fire. This red dots are number of times a pixel has burned. Kasanka National Park in Zambia, which is a beautiful Miombo park known to be the largest bat migration in the world. And in this ecosystem, they burn the whole park in June, like almost all of it burns. But because it's June, you can see these fires are so small and creeping. None of these stems of the trees have actually been burned at all. The fires just burn gently underneath and remove some of the flammable grassy biomass, but there's very little impact on the tree layer. to the point that a small little path like that can stop a fire. So even though you see large burned area in these environments, doesn't necessarily mean that the fires are intense or that it's removing a lot of biomass. But intense wildfires are actually needed to maintain open canopies and grassy understories. So these sorts of fires that burn maybe later in the season with more biomass and then do top kill many of the trees and result in these very open expanses after the fire are also a really important part of the fire regimes and really necessary to conserve all of the biodiversity in these environments. And evidence for this is scarce, I suppose, like experimental evidence. There's an amazing fire experiment that our colleagues in Zambia have been maintaining since the 1960s, Makwera Forest Reserve, which is a unique example. Well, it's not unique. There are maybe 3 or 4 in the whole of Africa where we can go and we can see the effect of late intense fires, early fires, which burn creepily under the understory and don't remove much woody biomass, and no fires at all because they've managed to protect a small area of this flammable landscape from fire. They had a couple of wild ones, but pretty much no fire for the last 60 years. So you can immediately see that there's a huge change in vegetation structure depending on the intensity of the fire. These early and late fires both happen every year. It's just about intensity. And if you look at the biodiversity in these ecosystems, if we're just looking at the plants, you'll find that in the tree layer, even though we've had 60 years of really different fire regimes, there's quite a lot of overlap still between the plants that are in these systems. There's a little bit of distinction between the late fires. You have some plants that are only found in the late and some only in the early, but most 30% overlap between all of the treatments. But in the ground layer, in the grasslands, and all the forbs and other plants that are in the ground layer, there's a much more turnover because these are the ones that are affected by the change in light conditions that happen when you have these extreme fires. So you'll find that there's hardly any overlap, only 11% overlap between the treatments, and that the late fire and the early fire have pulled apart, and we have unique species in each of these habitats, even though they're just a few hundred meters from each other. And Caroline and her colleague Jacob explored this more generally globally, because that's just from one field experiment in Zambia, to show that it's really true that when you have increasing tree cover in these tropical ecosystems, you reduce your herbaceous plant diversity. So this becomes quite a challenge because it basically means that fire management in savannas needs to engage with these trade-offs associated with changing tree biomass. If we have unique plant communities adapted to different types of fire regimes, then there really is no one size fits all, as Abby was saying so clearly a few minutes ago. So I've talked mostly about plants, but we do have some information about what happens to the other components of biodiversity. And certainly, I think the Australians are leading the way here in terms of understanding how fire regimes in these tropical systems can affect different components of the biodiversity. There's a study that we looked at in Africa where we were just zooming in on the small mammals and the birds to see, because these are both organismal groups that are really affected by vegetation structure, to see how these types of organismal groups might be affected by different types of fire. So we created this concept of pyrodiversity. As many people have said, as both Abby and Chenga have shown, there's the area burned, there's the size of the fire, there's how intense the fire is, there's the season that it burned. And if you take all of these characteristics and sort of group it into one index, which is how diverse is a fire regime in a landscape, our question was whether if you have more diverse fire regimes, like a wider range of intensities and seasons and frequencies in a landscape, do you end up with more richness of birds and small mammals? And this was a study that we did across Africa. So each of these dots is a national park in Africa, which had a list of species. And you can see that as you go into the high rainfall ecosystems, the ones that Abby pointed out are the most sort of determined by fire, you seem to be able to maintain higher bird and small mammal richness if you have a wide range of fire regimes. And so these blue areas here that are less diverse, they could be less diverse because there's hardly any fire, or they could be less diverse because all of the landscape burns all of the time, like in Kasanka. But the fact is it's just less variable. And then you end up supporting fewer bird and mammal species. So I think that's really useful for us to take away and think about. So the conclusion for this is that we really need to make room for extreme wildfire in our management thinking. It's comforting to think that if we can just use fire and tame it and make sure that we still apply fire in these systems, but in a way that's less worrying and dangerous and uncertain for us, then we'll be looking after these ecosystems. But the evidence is coming that no, we need to recognize that extreme wildfires are part of their functioning and maybe quite an essential part of their functioning. So I think my conclusion from all of this literature that I've reviewed over time is that flexibility is really required, and that it sometimes helps just to think, what is your conservation question, and to kind of define your fire management goal around the conservation question. And a nice example of this is in the Kruger National Park, where just within a few sort of kilometers of each other, because the soils are different, they have two totally different management goals. On the granite soils, where they're really worried about the woody encroachment and losing the biodiversity, they're aiming to have these intense firestorms that will knock back the trees. Whereas on the basalt soils, where the grass biomass is already so high and we're having so many sweeping wildfires, we're really making very uniform fire regimes there. They're aiming for reduced patchy burns. So early season burns that burn less of the landscape and are cooler. And that seems to me, and so the sorts of fire management plans that Amos was talking about and the engagement with what the local people need seems to me key for any form of fire management in Africa. So just to conclude, I think we have got quite a lot of evidence, and it's accumulating, that biodiversity is enabled by varied fire regimes in these systems. And this is probably due to varied vegetation structure that results from varied fire regimes. And this is because you get really high turnover in both birds and small mammals and plants between open and closed canopy communities. And this does raise conservation concerns for the types of projects that Abby was talking about, aiming to abate fire in order to increase above ground woody cover. There's often the sort of one-liner at the end saying, but yes, we should also be thinking about biodiversity. But the point is that changing woody cover does change biodiversity, and fire is intimate for that process. But I'd like to spend the last few slides talking about fire-sensitive aspects of the biodiversity, because up to now I've presented data on these savanna ecosystems where fire is a regular and predictable part, and where we have these organisms evolved with fire, and that in some cases depend on fire. But as Caroline mentioned, we do have some very interesting and important fire-sensitive tropical vegetation formations, these little islands within these fire-prone grasslands, which are quite fascinating. And they are not a small part of the landscape. They stretch across many hundreds of kilometers, not only in Madagascar, across the whole of tropical Africa, across South America, and I'm sure in Asia, and definitely also in Northern Territory, Australia. You will find pockets of plants that are persisting within a fiery landscape, but are incredibly sensitive to wildfire. This is a satellite image from the top. And there's been a lot of learning about these ecosystems. And there's a wonderful paper by Annabelle Cardozo that came out a few years ago, showing how these systems have evolved. The fact is they are really quite fire resistant when they are not damaged, and they haven't been, their resilience hasn't been decreased. And so you can have these grassy fires spreading that just stop at the edge of these boundaries, because there are really interesting ecological processes. In this case, a combination of very fire-resistant species on the edge and elephants making little fire breaks as they walk around that stop the fire. But the other learning is that the moment we degrade these ecosystems just a little and reduce their fire resistance, then they can become quite susceptible to extreme fires. So we really need to learn from each other across different parts of the tropics about how to enable these systems to be fire resistant. And the point that Caroline made is that sometimes the best way to keep them fire resistant is to make sure that you're enabling these frequent cool fire regimes and not allowing a lot of biomass buildup. And then another fire-sensitive tropical vegetation that is perhaps less well known are peatlands. We have many tropical peatlands across the savannas, and most of these tropical peatlands, well, many of them, they are covered by grass. And this grass in the dry season cures. And so you end up with a system where you have an incredibly flammable grassy vegetation type on top of a peatland. And so it burns. They burn frequently and they burn in surface fires, so grass fires, but occasionally, and we're still not exactly sure when, the peat can burn. And so we really need to try to understand under what conditions these surface fire regimes turn into peat fire regimes. In this context here, that's that same beautiful environment in Angola where my PhD student is working, taken from a drone image from the top where you can see the peatlands and you can see how many surface fires there have been in these peatlands in this year. But I think, again, for both of these fire-sensitive vegetation, we need to remember that they're both very ancient vegetation types that have evolved with these fiery fire regimes. And so we need to enable them to be fire resistant rather than assuming that it's all going to be a devastating disaster every time a fire happens in them. So just to conclude, we know these ecosystems evolved with fire and that there are intimate associations between fire and biodiversity. We also know that tropical savanna fire regimes are really variable, depending on the season of burn, where we have the moisture content and weather conditions, and the grass biomass, and that we have some capacity to manage that as humans living and working in these systems. The evidence is also mounting that low severity fires are not uniformly good for biodiversity. They're good for protecting people and croplands and houses, but they're not always good for biodiversity because we have unique fauna and flora that are adapted to different fire regimes. And then we also know that we have fire-sensitive forests and peatlands within these tropical savannas. And my contention here is that fire in these systems is often a symptom of degradation. We have aspects of degradation and then the fire exacerbates it. And the fire is the most obvious way for us to see the degradation, but it might not necessarily be the cause. So there is room. I think we've really mobilized as a community over the last few years in terms of finding our understanding and ability to manage these fire-sensitive systems. And there's a lot more work to do. I'm trying out this idea on everyone, and I'd like your thoughts in the discussion. I've brought out that, like reducing fire intensity so that we have these fires that are easier for us to manage is not always an answer. So I'd like to sort of try this idea out that might help people in thinking about extreme fires in our systems, is that extreme wildfires are like elephants. I live in Africa where elephants are troublesome, and I'm sure Amos, anyone who lives in places with lots of elephants, elephants. Intense fires are difficult to manage and unpredictable, but so are elephants. And too many intense fires are really a conservation concern. I do agree with you. And too many elephants can also be a conservation concern. But I think what we realize more with elephants than we don't really realize with fire is that without elephants, we lose key drivers of ecosystem functioning. And without these occasional extreme fires, we are also going to lose key drivers of ecosystem functioning. And so that's a challenge for us globally, because globally we all care about these tropical ecosystems, but especially for us, those of us who live in these tropical ecosystems and are having to live with elephants and with extreme fires. But I think it's a challenge that we can rise to. Finally, I think it's really important to recognize that a bunch of information about fire ecology and biodiversity is not sufficient for understanding and managing wildfire because it's a social question. And there are lots of ways that we can engage better with society about fires and help them to understand wildfire better. And this is an example of an art-fire collaboration that I did with some colleagues, which really helped people in Johannesburg, where I live, to explore and understand their feelings about fire management. I just want to thank all the funders and the amazing colleagues that work with me on this. Thank you so much.
Thank you, Sally. That was amazing. Just such a clear illustration of why it's important to understand different fire regimes, different characteristics of fire regimes, and so many trade-offs involved with changing fire regimes and trying to balance human and ecological concerns with wildfire. We, of course, have gone past time, but I have a slide of questions, and I'm not sure if anybody is going to stay on. Of course, anybody is welcome to leave if you need to leave right now. I had a couple of questions. I know Robin had a few questions too. I will put them up on the screen. But I'll let Robin go ahead and direct any questions. I haven't been monitoring the Q&A, so
Yeah.
if you want to look at some of mine, if you want to ask your own, and
Yeah, I have a couple of questions that we pulled from the Q&A. So let's start with a couple of those, and then we can dive into these if we've got time. I would recommend that we don't take more than 10 minutes for Q&A
yeah,
at this
yeah.
point. So,
and also
okay.
that we do have a discussion forum, so we encourage anybody to. In fact, what I might do, instead of my questions, I'll give you the QR links. So if you want to come to the discussion forum and talk Savannas, please, you're welcome. So go ahead, Robin.
Okay. So I believe this is probably a question best directed to Abby and Chege. What do we know about how Indigenous fire practices and knowledge differ across regions? So Abby, you had made the comment that there had been a workshop in Botswana where they were applying basically Indigenous practices derived out of Australian Indigenous populations. And so I'm curious what we know about how these practices might differ or the knowledge might differ.
Yeah, absolutely. So just firstly, I think just one great resource to really explore this in depth is that the Leverhulme Centre have like a Just Fire working group and full of different people looking at like specifically looking at different traditional or indigenous fire knowledges globally. And Dr. Kathy Smith actually spent a couple of years putting together a global database looking at different fire practices globally from subsistence and small scale like agricultural communities but to divert like the reason like some people, for instance, if you're from more of an agricultural like pastoralist society, then you might burn for reasons regarding your cattle and the rangelands, but there's so many other reasons like farming agricultural communities will burn for different like land management practices, and then there's also all the cultural and spiritual reasons why communities burn, and that really does vary between these communities. But I would definitely recommend having a look at it's called the Life database. And it's available if you look at Dr. Kathy Smith and look at this huge database of all these amazing resources that highlight these just such diversity in burning practices. So I think there are some like key takeaways globally that you could say that maybe translate between like pastoralist communities, for instance, burning to reduce like pests and ticks and things like that. But the specific ways that they carry out those burns and the timing and things will depend on the community's seasonal calendar. So yeah, there's quite a lot of evidence emerging, and there's a kind of now huge focus on I guess Indigenous knowledge and practices and things, and that trying to represent the diversity in the conversation.
Thank you, Abby. We have another question. I believe that this is for Dr. Archibald. The question is, do we see vegetative type conversion in savanna ecosystems that shift the ecosystem composition over a long-term basis, as we do see in, for example, Mediterranean ecosystems?
I'm assuming sort of you mean veg conversion due to changed fire regimes.
Correct.
Um,
I think that's what.
Yeah, so I think our colleagues in South America have done the best job of monitoring that. They have been monitoring some of the Cerrado. Cerrado is the South American savanna. They're fragmented patches of Cerrado that are not now exposed to wildfire because they are very small and surrounded by agriculture. And they've been monitoring rapid transformation of these systems from savanna to closed canopy sort of forests, but still with savanna species, to then having them actually switch into Atlantic forest communities. So there's a total functional shift away from savanna into forest. And they've been highlighting biodiversity and consequences for water and all sorts of consequences. We have some data in our ecosystems as well, that similarly, if you reduce the fire too much, then you have a shift to a totally different vegetation type. But I don't think it's the same in Australia. I think I have seen very little evidence that reducing the area burned will change it into a totally different vegetation type. It will just alter some of the vegetation structure. And certainly the other way around, there are some wonderful examples. It's usually like a combination of fire with something. Like there's a really great paper from Murchison Falls in the 1950s where elephants came into a forest ecosystem and knocked down some of the trees, and that enabled light to come in to the understory, and grasses came in, and you had fire burning. And so the tropical forest was converted into a savanna due to the combination of elephants and fire. So yes, we have some really fascinating and interesting case studies across the tropics on that.
Thank you. For those of you that work in the Australian ecosystems, we had a question really about what the mechanisms are used to shift the fire seasonality in Northern Australia, similar to what you had mentioned in your talk, Abby.
Sorry, what was the question? Just how?
What are the mechanisms used to shift that fire seasonality when there's an effort to actually shift it to a different timing in the year?
Yeah, I think, well, in the Northern Australian context anyway, it's mainly to kind of carry out early dry season, like low intensity early dry season prescribed burns quite extensively across the landscape to reduce the fuel loads. So then as the summer develops and it gets increasingly hotter, you don't have those large amounts of accumulated fuel, hot like fuel that will easily burn. So, and similar to what's being carried out in terms of prescribed burning in Western the US as well. It's very much focused on these early dry season prescribed burns to shift the fire intensity.
Okay. That is it for the questions we had from the Q&A. Alexandra, was there any other burning question that you had for the panelists before we let folks go?
I had these questions that I have up on the screen, but I think we've kept people long enough, so I think I will let everybody go in the interest of them continuing on with their days, unless there are any closing remarks that any of our speakers want to make or ask questions of each other, or if you read my questions and you say, I really want to answer that, you can do that as well.
No, thank you for bringing us together. I think Caroline did a great job of answering many of these questions at the very beginning.
Yeah, this was such an excellent webinar, and it just flowed beautifully from Caroline all the way through Sally. Sorry. So I also wanted to mention to any of the registrants who are still with us, we will be sending out a link with a YouTube video of this in case you want to go back and review anything. There's a lot of really fascinating content, a lot of papers, a lot of citations that our speakers presented today. So you will be able to go back and review all of this online in just a short while or share with your colleagues. And otherwise, any last words, Robin?
Alex, I was just going to mention that this is intended to be the first in a
Right.
series of 2 webinars about savanna
Yeah.
ecosystems, because there is so much diversity and such a wealth of research happening in this arena. So if you registered today, you'll be on our mailing list, and we will be letting you know when that second webinar will be happening.
Excellent.
Excellent. All right. Thank you all for joining us today.
Thanks everyone for organising. Thanks, Alex. Thanks, Robin.
Thank you. Lovely to
Bye.
see you
Lovely
all.
to see you all. Thank you.
Bye-bye.
Thank
Bye.
you. Bye.
Bye.
Bye.